Right, so we're at top of the hour, minute past. We're going to start our webinar. Welcome, everybody. Thank you for having joined our webinar today on M-Bus and LoRaWAN and how these protocols strengthen each other with a close-up on heat metering. My name is Anne. I'm the Director of Vertical Markets at the LoRa Alliance, and I'll be moderating this webinar for you today. So before we dive into the main topic, I will give you a quick introduction on the LoRa Alliance and the LoRaWAN technology. And after that, I will introduce you to our panelists of today. And at the end of the presentations, there's obviously time for a Q&A session during which we'll do our best to answer all of your questions. So if you have any questions during the presentations, please drop them into the Q&A box on your screen and we'll answer them after the presentations. So let me start by giving you an overview of the LoRa Alliance. The LoRa Alliance is a non-for-profit organization that plays a key role in the evolution of the Internet of Things, thanks to a technology called LoRaWAN. And I think many of you are familiar with that technology already. So LoRaWAN is a technology in the LPWAN segment that stands for Low Power Wide Area Networks. And key advantages of the technology are the fact that devices can run on very low power, and thus have a very long battery life, sometimes even up to 10 years, and over multiple of kilometers, up to 15 kilometers, which are longer distances than some of the other existing protocols allow for. Additionally, LoRaWAN technology can be deployed in rather complex wireless environments, and it's able to penetrate through walls for deep indoor deployment. LoRaWAN has low data rate transmission. It has extremely long battery life and is deployable in many different structures. It's an open source protocol, which pretty much means that anyone has access to it and can easily join the ecosystem. The Alliance as an organization was founded in 2015 by a couple of founder members, and it has rapidly grown into a structure of multiple hundreds of organizations all over the world. So the Alliance, as you can see here on the screen, includes some big players such as Machine Q, Orange, Cisco, AWS, and many others. And thanks to this ecosystem, companies can collaborate closely to enhance the LoRaWAN protocol and offer certified and secure solutions to the market. The Alliance has three main goals, which are to develop, maintain, and standardize the LoRaWAN open source protocol, used everywhere to roll out the network and connected devices. Secondly, to certify devices to ensure interoperability between LoRaWAN solutions. And third, promote members and their products and solutions, which is something that we'll be doing today in this webinar. LoRaWAN has become the de facto standard for LPWA networks, with networks, as you can see here, in 161 countries all over the world, and 143 operators having deployed networks already. On this slide here, we can see that the LoRaWAN ecosystem is made of. So members of the Alliance range anywhere from chipset manufacturers to system integrators and anything that comes in between, as you can see here. IoT connectivity with LoRaWAN starts with either the basic radio chips or the modules embedding the LoRaWAN protocol stack, which are then used in devices as wireless modems to communicate data over networks, which can be either public or private. It is very important to remember that everything in this value chain is ultimately about data. So data is collected by network servers and forwarded to application servers that make the data accessible and easy to read by the end customers. So that's the ultimate goal. In a nutshell, this is how LoRaWAN enables the connectivity for the IoT. And our speakers today, that you will hear later on, each represent a different element in this IoT value chain. Moving on to a couple of differentiators and benefits of LoRaWAN. So on this slide, we can see that one of the biggest assets that LoRaWAN provides is that we can either use a public or a private network to use the technology and to gather data. Public rollouts, they are rather similar to the classic cellular networks, whereas private networks can, for instance, run as well with Wi-Fi and can be either completely self-managed or with support from ecosystem partners. In addition, LoRaWAN is a bidirectional standard, which makes it easier to run firmware updates over the air to update devices very easily without having to go look for them. It has very secure encryption with 2 layers. So one is for the actual link and the second is for the payload. So that is much as like with cellular networks. The network provider cannot see the data that is passing through. Only the end customer ultimately will be able to see the data. and this makes it a very secure technology. As we mentioned before, LoRaWAN is very energy efficient, battery life anywhere from 5 up till 10 years. And this means that you can avoid having to change batteries by accessing often remote or complex areas. So sensors are also low cost, and the network has an easy setup process. So I would now like to introduce to you our speakers and our topic for today. The topic that we have put central for you is heat metering and how heat metering becomes smart when using protocols such as LoRaWAN and MBus, and more importantly, how these two protocols can strengthen each other by collaborating. So one aspect of heat metering is district energy, which is an intelligent, environmentally friendly way to ensure sustainable heating and cooling in buildings such as schools, homes, but also in entire neighborhoods. A growing number of cities worldwide are actually adopting modern district energy solutions as the best way to bring sustainable heating and cooling in dense urban environments. And our experts today will present to you how heat metering has become increasingly important over the past years, and how solutions are implemented from both a practical and technical standpoint. So we're going to start today with Hannes Gütle, who is in charge of data and energy management at KELAG, followed by Emil Tiren, Chief Product Officer at Elvaco, and we finish with Ahmed Kastet, Head of Innovation and Standards at Birdz. So KELAG is the largest district heating network supplier in Austria. And Hannes will be presenting interesting real-life applications of heat metering and an evolution throughout the years. Emil will then present a market overview as well as their end-to-end solutions and products that enable heat metering applications, being the provider for connected meters and sensors. And Birdz is the IoT company dedicated to environmental applications and will zoom in on rather technical aspects of both the LoRaWAN and MBus protocol, explaining the benefits and the way these two protocols can cooperate. So with that, I would like to pass on the word to Hannes Gütle. Hannes, you have the floor. Hannes, make sure to unmute yourself.
Sorry, so yeah. Now it's working, okay?
Okay, yes, we can hear you.
Okay, thank you, Anna, for this introduction and also for the invitation to present our company and our experience and our way to LoRaWAN and which yeah, the experience we had right now. So I tried to make an overview, started with a few words to our company. As Anne mentioned, KELAG is the biggest heating district heating supplier throughout Austria. So we have really a very, very long experience, over 50 years in heating network solutions. And right now we have 230 employees with about 12,000 customers, and really a big amount of heat we supply. Today I present also the company Kelmin. It's a daughter company of us, and Kelmin is specialized in our area and managed all the heat cost allocators and offers consumption-based billing in all different standard levels. And this is also the company which is driving our own private LoRaWAN networks. Next slide. I wanted to give you an overview how our history. And KELAG developed for his own district heating, but in 1999, 2007, we bought subsidiaries from the big mineral oil companies like Exxon and Shell, the companies Wärmebetriebe and Österreichische Fernwärme, and we merged together in 2008 to KELAG. Wärme itself. So at this time, we started with the first readout of heat meters on a radio, with radio communication. At that time, the technology was directional and bidirectional. So we decided then to go in the unidirectional way, which is more or less today the wireless M-Bus. And in 2012, we have been 100% of all our heat meters are really remotely readable with wireless M-Bus and with wired M-Bus. But in 2018, and the next slide, please, we in 2014 we tried then with this wireless M-Bus fixed network solution, and in the fixed network solution the components has been the same than we have right now today. We have the meters, we have antennas, we have the receivers, today the gateways, transfer some software and some data. So the system architecture has been the same. We tried to realize some fixed networks. Next slide, please. Especially in our hometown in Villach, and due to the special geographic situation, we mounted gateways on the top of the mountains, which are surrounded in Villach, and we covered at that time 70% of the city of Villach, and we had a readout of values from heat meters in a distance of 10.95 kilometers. So this was really sensational at this time, but we didn't go on with this because the technology and the point of cost of metering has been really too high to develop really fixed network solution with an readout and with an automatically readout in a range of a daily or hourly rate. So we kept this at that time and started then. Next slide, please. In 2018 with LoRaWAN, and with LoRaWAN, especially with our daughter company Kelmin together, and we started here all the solutions you may know in case of smart city with metering and sub-metering. So this was the experience we had in the past, but the decision to start with LoRaWAN was not to change the technology which we had 100%. The change was really to get the IoT market in addition. So with the LoRaWAN, we get immediately different other use cases like smart parking, smart waste, smart lighting, smart buildings, and all the application I mentioned on the right side. And so we tested this, and again in our hometown Villach, we set up the first LoRaWAN network, changed in the first time our meters, second then the sub-metering and the heat cost allocators, and started to realize application in energy efficiency and other use cases with which I mentioned already. Okay, next slide. But we checked out immediately that to develop an LoRa network, we need some information, and you could imagine when I go to the mayor of a town and said, okay, we develop an LoRa network. He said, okay, how many gateways I have, what is the situation, even in our point of interest. I had to calculate in the beginning about the network, how many gateways I need to cover my area to cover my network on the side of district heating. And so we have a lot of question really for this, where I have to install the gateways, which are the ideal gateway locations, which range of gates and site I have, the heights and the surrounding. So try to get in a calculation and to check out, and we see immediately, okay, we have a missing information. We don't know the radio propagation. We don't know information to calculate the network. So we started to develop a network simulation. And next slide, please. And yeah. And started with the network coverage. So the question is always the path loss. So the path loss in case of reduction, the power density in case of electromagnetic wave through the space. So which is the path loss, the signal strengths which I get at the very end of the meters. So there are a lot of contributing factors, and with this information, we try to get in a modeling approach, and we said, okay, which information we have, are there experience, are there available software in this, and we tried to get the information to check the situation on the focus of ray tracing, deterministic models, semi-empiric models. And ray tracing is just for indoor application. Deterministic models are just for the communication from Earth to satellite. And then we focused out really that the semi-empiric models are really the models with which we are able to calculate the networks and to develop the network. Next slide, please. The semi-empiric models, there are really a big variety of different models. The models to calculate in city like Singapore or in city like Philac is different. I have many influencing factors for the modeling, statistical, some different parameters are what has been empirically founded, and we have in any case tailored specific problems with each town, with each solution we had. So we focused out and special models. We said, okay, 868 megahertz frequency band. The calculation range was up to 11 kilometers. The surrounding influence, and this was very important for us to get really urban, suburban, and rural. So this is the situation we have in our country, and yeah, some possibility to take terrain data which we normally buy into the model. Okay, next slide. And with this simulation tool, and this was then an in-house development, because the existing models from the telecom industry has been much too expensive for us, and always focused from air to air, and not the situation we have from ground or above ground, several meters under the surface to the gateways mounted in a higher position. And we developed this simulation tool for our own, and at the very end we have been able to simulate this on Google Earth or on cookies. And right now you see a picture for the simulation. We made a layer for Google Earth, and then we had a clear focus of the area which we could cover, and what is the propagation from that point. Okay, next slide, please. Then what I want to tell you as well is the difference in the gateway density, because the situation we mentioned, and I mentioned already in the presentation, is for example, the city of Villach, and this is the existing model. This is right now done. Just to calculate on a urban area, I need one gateway. To have indoor, I need to cover the city of Villach. In case of indoor, I need 12 gateways. And to cover deep indoor, so in the second cellar, or really in the manhole on the one water supply on us, I need really for deep indoor coverage 28 gateways. And I get also in the beginning the question, the package loss in case of indoor and deep indoor. So you could calculate with 15 to 20 dB decibel loss from outdoor to indoor, and again then 50 to 20% from indoor to deep indoor. So deep indoor package loss is approximately 40 decibel. That you have an idea what is here the range of the package loss. Okay, next slide. Yeah, this was a situation we had right now. A funny thing. We developed the city of Linz and made some heat cost allocator in a living area there. We mounted in summertime this year approximately 7,500 heat cost allocators. And then I asked them, okay, we have mounted 2 gateways on a chimney in that area. What is the coverage? How many of these heat cost allocator we get? And the colleague which made this calculation come to me and said, oh, I'm not so happy with this. We get mainly, but I have some bad connections. I marked this in the picture with the with the yellow and the red buttons. Have a check and look at this. I don't know what is this situation and how we to go on in that project. And then I get the picture, and it's true. In the city, also in the center of Linz, we get the heat cost allocators from Enns, and this is a town 50-kilometer distance, and on the left side Kirchberg, this is 9-kilometer distance, and they said, okay, the signals are not strong enough to have 100% package, where we have too much package loss. But this is the truth, and I used this photo because it was really a funny thing what happens by us. So no, but also, but this is really and good information of the LoRaWAN network and of the long range which Anna mentioned. Next slide, please. So our experience right now with this history from the wireless M-Bus to the LoRaWAN. Right now we have more than 37,000 devices in case of sensors, meters activated in our and again private LoRa network. The greatest distance we had, this is 50 kilometers, which I showed you in the picture before. The experience in the rollout is really that deep indoor is a challenge. Deep indoor is a really challenge because there are so many factors which influence then again, and which we are right now not able really to calculate because there is no simulation model available. But we get every day new values and new information to do this. But it's really a strange thing. We have right now currently 500 gateways in operation in Austria. Yeah, within next year, we are developing 10 cities with district heating and made a rollout of 4,000 more heat meters, which is planned for 2020. 21 and 22. And at the end, very important thing for us, and this was also the partnership with Elvaco. The metering market is really very well developed. The metering market is, you get right now more or less from all suppliers, LoRaWAN modules. They are in a quite they are in quite good conditions. We are happy with the modules we get from Elvaco, because all of them, all meters, all suppliers we have, they covered with their experience. And the biggest challenge is the IoT market, because all these smart city projects, we need a lot of IoT, we need a lot of sensors, devices, and yeah, every day are coming new application, new sensors, and they are just developing because there is a big hype. But again, back to Elvaco, the key thing is the key management. And when you made a rollout with 4,000 heat meters, you need a key management which really works properly, because all these small companies, they are providing IoT sensors. They have problems to deliver the keys in a certain way that we could insert that automatically to all the quality and safety rules. And here in that reason, the key management is for a bigger amount and rollout one of the most important thing. When we did our homework, and we developed the network, and we get all the sites for the gateways, and when this is done, then it's really the experience we get from Elvaco with their modules and with the key management. And key and device management is at the very end the most important thing. And here we had still development in our company, because we need all this information then at the end in our systems. But we are on a good way, and with this partnership, we are really quite happy. So this from my side. Annie, I don't know, do I have been in time?
Yes, no, you're good, Hannes. Thank you very much for the presentation. I see that there's a couple of questions for you that we will address afterwards. So I'm going to move over to our second presenter for today, Emil Tiren from Elvaco.
Thank you, Anne, and hello, everyone. So listening to the previous presentation actually made me think of a Chinese proverb saying something like, when the wind starts blowing, some build walls, now they set sails. And I think KELAG and Hannes Gitter has definitely set some big sails. It's a very impressive large-scale IoT system. Yeah, thank you, Hannes, for a great presentation as well. And we at Elvaco are, of course, very happy to be in a small part of making this possible. I have to admit that back at the time when we started to work with LoRaWAN technology, I would never have guessed how fast the wind was really picking up. So very happy to be here today and to see this big interest in LoRaWAN and in particular the heat application. So my name is Emil Tiren. I work as a Chief Product Officer at Elvaco, and in about following 10 minutes or so, I will give a brief presentation of Elvaco for those of you that are not so familiar with us. And maybe more interestingly, I will also try to share some of our thinking around IoT solutions for the heat application and weighing in on the importance of standardization and interoperability. Next slide, please. Okay, so some dry facts about Elvaco. We're a mid-sized Swedish company with a quite strong international footprint. We have business worldwide, although we're naturally centered around the European and also a quick mentioning that we're part of a group is working with different aspects of energy efficiency called BEMSIC. And at the top, we have one of Sweden's largest private investment companies, Latour, a typical long-term industrial owner. Next slide, please. Next slide, please. Anna, can you hear me?
Yes, I can. Is this the right one? Or we need a previous one?
Thank you. Okay, so yes. No, sorry, back one step. I don't know if it was maybe delayed on my screen. It didn't look like you switched the slide. So one back.
I think we've got it now. Is this the one?
Towards 2 slides there. It's my screen, it's showing global market share. This is the one. Yes, perfect. Thank you. Might have been some lag there. So, okay, so if we have a quick look at what we work with and have done over time, we have some 30 years of history in developing connectivity solutions for the utility and the building markets. And I would almost like to say that we've been in the IoT space long before it was even called IoT. And almost a bit of a funny side story is that a few years back we were called up by quite a few of our old customers that said that we need help to, and we replied, that's not a problem, you're already there, since all of their meter parks was already connected. I think there's a good takeaway from this. Even if technology development is fast, you should not let it cause you lose the purpose of what you want to achieve. If you look at our technology portfolio, it's broad, but we see ourselves as a solution provider rather than a tech company. That means that we constantly scan and look at new technologies and employ those that we think are useful for building good solutions rather than
It seems like we have lost Emil, everybody. So let's give him just some time to come back, and otherwise we'll skip to the next presentation.
Yeah, sorry.
Yes, Emil.
Yeah, sorry. Can you hear me, Anne?
Yes, we can.
Yeah, thank you. Sorry, I think to have some really bad timed communication problems here. So let's push on and see if it stabilizes what happened here. Good. So market share for heat meters, EMEA. Is that the slide you have up?
That would be this one.
Yeah, I see still here, but if you have that slide, that's good. Perfect. Now I see it as well. Good. So with all the buzz and talks about IT and wireless technology, you might think everything is wireless today. But however, as you can see, there's still a significant share of heat meters sold that is using new communication today. And part of IT is, of course, to change this. And actually, we think there are some good reasons for that to happen. In our opinion, the trend towards wireless communication will be even stronger than suggested this market analysis. And into that, we factor that actual technologies do deliver on their performance specs and are available at acceptable cost. And also considering that a lot of the solutions made today, the metering side is available for retrofitting, which makes it easy to non-communicating meters that's already deployed in the field. And also on the legal side, important to remember to the Energy 2012 has stated that from
Right, we seem to have lost Emil. Emil, can you hear us? this is going to be a bit tricky. I would suggest, Ahmed, you take over for now, and we'll give Emil a chance to get back to the presentation. So I'll move over to your slides, Ahmed.
Thank you, Anne. So thank you, Anis, for your interesting insights and experience regarding LoRaWAN and wireless MBus. And thank you, Emil, also for your inputs regarding Elvaco's history. So hello, everyone. My name is Ahmed Kastet. I'm in charge of innovation and standardization activities within Birdz. So Birdz is a branch of the French group Veolia, which is the global leader of utility and energy services. Birdz enables its customers, mainly municipalities, to operate an efficient digital transformation thanks to its end-to-end IoT solutions. We are 170 employees and have more than 20 years of experience in metering, wireless connectivity, and digital data platforms, targeting water, waste, energy, and oil and gas verticals. We have delivered more than 7 million connected devices with 3.4 million operating in automated metering infrastructure and sending nearly 38 million messages per day. With a single hardware on these devices, we are using both LoRaWAN and wireless MBus protocols to give a maximum flexibility during deployments and operations. Today, I'm going to present you two major protocols used in smart metering and how we can combine them to get a very powerful and future-proof solution for smart metering and smart utilities applications. Of course, you all know the LoRaWAN protocol developed by the LoRa Alliance, but I'm not sure that you know much about the M-Bus protocol. So next slide, please, Anne. Yes. So M-Bus is an European standard based on the EN 13757 series, dedicated to the remote reading and monitoring of heat meters, and it is also usable for all other types of consumption meters, as well as various sensors and actuators. The EN 13757 is the set of specifications dealing with the entire protocol stack layers, from the physical and link layers up to the transport, security, and application layers. In the early 90s, the MBus interface was made for communication on two wires, making it cost-effective. But in the mid of 2000, a radio variant of MBus called wireless MBus has been developed to provide an easiest deployment solution. Wireless MBus uses FSK modulation in the 868 MHz band and features 4 different radio modes, mainly using high data rates to provide short signals, enabling very low power consumption and hence long battery lifetime. But this advantage came at the expense of a short-range communication, making the deployment of wireless MBus network infrastructure expensive for meters located especially in deep indoor conditions, like Hannes explained before. So to get more details about the costs and benefits of LoRaWAN and wireless MBus, let's see the benchmark of those two protocols in the next slide. So here we have a comparison of both LoRaWAN and wireless MBus according to different technical and operational metrics. So let's start with the first 3 technical metrics. So as I explained before, the FSK high data rates of wireless MBus leads to a short range communications, but it enables a very low power consumption and large payload size. While LoRaWAN features low data rate, enabling a long-range propagation with affordable power consumption and suitable payload size for metering applications. But one of the major differentiators between LoRaWAN and wireless MBus is the standardization of the application layer. MBus payloads are specified in the EN 13757-3 specification, whereas LoRaWAN deals mainly with the physical and the link layer and has no relation to the application layer. Another element that distinguishes them is the possibility to use public radio networks infrastructure. So while wireless M-Bus radio gateways should be deployed in private modes, major European telcos provide nationwide LoRaWAN coverage. So both technologies have a quite wide ecosystem of manufacturers and providers, but LoRaWAN has a definitely wider and stronger ecosystem thanks to the work of the LoRa Alliance. And finally, while the LoRaWAN adoption in the metering applications is still growing, MBus is the leading and the reference protocol, especially in Europe. Next slide, please, Anne. Thank you. So to summarize this analysis, we could say that currently we have two separate approaches. Wireless MBus in MBus application is suitable and well established in smart metering, but wireless MBus in the 868 MHz band does not provide long-range radio performances to tackle deep indoor conditions. But LoRaWAN's radio provide long-range communications, but it is application agnostic, and therefore utilities should develop new interfaces to cope with proprietary payloads encoding and decoding formats. So given this situation, the idea is to bring wireless MBus and LoRaWAN together because they complement each other. So with this approach, LoRaWAN will benefit from the MBus application layer standardization, while MBus will benefit from LoRaWAN's radio performances and network deployments. In addition, MBus and LoRaWAN will strengthen the ecosystem of each other. So let's see other benefits of this approach in the next slide. So by using MBus standard application layer over LoRaWAN, we could achieve several winnings. So utilities and metering industries could rely on telcos infrastructure and know how to get rid of the burden of deploying and maintaining radio gateways and mutualize the radio infrastructure with other smart city applications to lower the cost of connectivity. In addition, the flexible deployment models allowed by LoRaWAN enable the cooperation between private and public networks in roaming scenarios. One of the other major benefits of running MBus payloads on top of LoRaWAN is to preserve the interoperability and backward compatibility of utilities' legacy hidden systems. This approach will also widen and strengthen the ecosystem of solutions dedicated to smart metering and smart utilities applications. So smart metering applications provider could also get access to the open source reference protocol stack implementation to speed up their development. A certification procedure for both application and radio layers will guarantee the interoperability and increase the efficiency of deployments. And finally, because LoRaWAN features different radio profiles for every geographical region in the world, European industries will be able to export their solutions around the world. Next slide, please, Anne. So in order to achieve this MBus and LoRaWAN cooperation, we are targeting to use the adaptation layer approach developed within the CEN TC294. So the CEN is the European Committee Standardizations, and the TC294 is the technical committee of CEN dealing with communication systems for meters. So during this year, the CEN TC294 national members voted in favor of the new work item proposal aiming to develop an adaptation layer serving as an interface between MBus application layers over LP1 technologies different from wireless MBus radios and developed outside of the CEN TC294. LoRaWAN will use this standardized approach to benefit from MBus advantages. So to further this approach, a dedicated TC294 Working Group 7 called Adaptation Layer has been established and held its first kickoff meeting yesterday to set up the framework and timeline of this standardization activity. So let's see in the next slide what are the general architecture and an overview of this adaptation layer. Next slide, please, Anne. So in this slide gives an overview of the general architecture of how M-Bus application layers could be used over LoRaWAN using this adaptation layer. So as you can see, wireless M-Bus physical data link and network layers will be replaced by LoRaWAN, where the M-Bus adaptation layer will serve as an interface to connect LoRaWAN to M-Bus application transport and authentication and fragmentation layer in a seamless way. With this architecture, no changes are required at the application and the higher layer of the existing and legacy head-end system, and therefore will preserve the interoperability of those systems. So I hope I had give you a clear overview of this adaptation layer approach, and we will keep you posted regarding the developments and the updates of this work. And stay tuned, and thank you for your attention. Back to you, Anne.
Thank you very much, Ahmed, for this complete overview of these two protocols. So I would like to see if Emil is back in the game, and if we can give him a couple minutes back to present his slides. Emil.
Yep, I'm here.
You are, great.
Yes,
okay, so
I guess that's the downside of working from home with the consumer-grade routers.
Exactly. Let me go back to the slide of your preference. So I think we left it off at slide number, which for us is number 25. So I'm going to try this. Would you like to pick back up here?
Yeah, we could do that, definitely. So you let me know if audio gets choppy here again.
Yeah.
Yeah. So with all the buzz and talks about IoT and wireless technologies, you might think that everything is wireless today. But however, as you can see, there's a significant share of the heat meters sold that's still using wired or new communication. And part of the promise of IoT is, of course, to change this. And actually, we think there are some pretty good reasons for that. In our opinion, the trend towards wireless communication would be even stronger than suggested by this market report. Mainly basing on that new technologies do deliver on the performance specs and are available at an acceptable cost point. Secondly, considering that a lot of the solutions made today for metering is also available for retrofitting, which makes it easy to convert non-communicating meters that's already deployed in the field. And then thirdly, also looking at the legal side, the amendment to the Energy Efficiency Directive 2012, which has stated that from October the 25th of October 2020, all newly installed heat meters and heat cost allocators are to be remotely readable. Next slide, please. So what does the heat market look in terms of suppliers? Well, today it's dominated by 6 major players, together representing slightly above a 50% market share. And I'm very proud to say that for those 6 major brands, Elvaco is now supplying solutions for 5 of them. I think that's a strong message when it comes to the availability of LoRaWAN for heat solutions. Next slide, please. Looking at the portfolio more concretely, this is how it looks in terms of meters when we summarize our partners' offerings. So as you can see, if you want a LoRaWAN solution for heat application, you're not confined to a specific brand. And all of these solutions are also possible to retrofit in meters already deployed. Next slide, please. So if we zoom in a little bit further on the heat application and in relation to Hannes Gytler's great presentation, if we look at the total offering from Elvaco, there are many places that our products can be used, from production to optimization operations using data analysis. But when it comes to LoRaWAN specifically, we think that consumption metering for building and sub-metering is 2 applications with a very good fit. Say geographically, buildings are usually relatively clustered when we look at what's being served by a heat grid, and requirements in terms of resolution, meaning how often you wish to receive values, and quantities of interest, meaning what you want to look at, or within the capabilities of the technology. So placed in the context of this kind of complete chain, this is here you will find our LoRaWAN connectivity modules for heat meters and also temperature sensors. Next slide, please. So on the technologies, we currently focus on LoRaWAN and MBIoT for new solutions. There is plenty of work done for comparing the two, but get into that subject here. Just let me say that I think there's a place in the IoT space for both, and it's also important to look at other factors than just technology specs. Get a bit more into that on the next slide. However, when it comes to LoRaWAN technology specifically, there are some strong points. You can actually stay on that slide, Anne. Sorry. That makes it appealing in our mind. Of course, it offers excellent penetration or range, if you wish, and battery performance. And these are the typical key performance factors for IoT technologies. Something else that's very good when considering operations of this one can let you choose between building your own private infrastructure or use an operator, or even have a hybrid solutions. You might own the infrastructure, but someone does the services. And the last point, and I see that's the first point actually on this slide, sorry. It has a standardization, you could say, high up in the layers, which includes mandatory security. And this means that there's an interoperable and security-wise vetted solution right out of the box. And I think the importance of the last point is something that is often overlooked when talking about technology standards. If you, for example, take two products using TCP/IP over Ethernet, it doesn't say anything about interoperability or nor security, as there might be completely different protocols running on top of that. So important part when understanding a new technology standard is actually to look at it from a protocol layer standpoint to better understand what it includes and doesn't include. And that's also very important when thinking about interoperability. Next slide, please. So continuing on the topic of standardization, and more specifically what is not standardized in LoRaWAN, namely the payload data. And that is how the actual, say, measurement data is formatted, and it's for a good reason. LoRaWAN wasn't intended for specific applications, but of course, when you develop solutions, products, this needs to be defined. So we've seen a lot of examples where manufacturers try to find the optimal payload format for a specific application. However, our reasoning is that many other factors is actually influencing the suitableness, say, of the payload format rather than, for example, making it optimally compact for a particular product. We thought about this actually a great deal at Elvaco, and we conclude that there are some very good reasons for adopting part of the M-Bus application layer for our LoRaWAN products. In terms of fitting into a short LoRaWAN telegram, it's reasonably compact, but I think more importantly, looking outside the technology box, there's already a very large number of systems using M-Bus and a lot of people comfortable with working with it. Next slide, please. So continuing a little bit on talking about factors outside the actual technology, I think these could be at least as important or even more important than the technology performance specification. And just to take a few examples of things that could be worthwhile consider. Network infrastructure, how should it be operated? Your own networks rely on telecom operators, or is there something now there? What would be required in the future? Integration with other product systems. How does the new solution fit that you're designing fit together with existing or other new systems? Also thinking about there's a lot of value to be captured if you can, say, break the silos and use data from multiple types of sensors and meters. I think Hannes touched on this in a very, very interesting and good way as well in his presentation. And also process and security. Thinking about the complete process from commissioning to maintenance over time. How will the solution be deployed and maintained in a secure way? So to summarize, don't just put all effort into technology investigations, but also look at the complete process or journey, if you will. Next slide, please. So my last slide, and maybe a bit of a commercial break before the Q&A. But I wish to take the opportunity to highlight some of the Elvaco additions that's done outside the scope of LoRaWAN that are very important for a real-world solution to scale. I think we all heard a lot of times about the great battery performance of LoRaWAN, but also the actual lifetime of a battery is affected by the signal conditions. So we have implemented something that we call Eco Mode, which adds smartness and predictability around the battery lifetime. And also, Hannes also touched on this in a good way. LoRa has a good end-to-end security, say, built in, but there's also questions about how to handle the real-life logistics of keys. And all our products support what we call the OTC concept, which includes a secure and digital management of the product logistics and life cycle. And lastly, with the adoption of M-Bus application layer as a payload format, that we aim to give smooth transition as possible to a LoRaWAN based solution. So with that, I was a bit rushed there, but I was going to hand over to Ahmed, but I guess Anne, you'll take it from here.
Yes, I will.
Thank you very much for listening.
Yes. Thank you. So we do have a couple of minutes left for a Q&A, and I see there are quite some questions. What I'll do, I'll pick a couple of them here to reply in live, and for all the attendees, we're going to do an extract of your Q&A and have all of our speakers reply to them in written that we will then send to your emails for a complete overview. Just a couple questions here. So Emil, for you actually. There's a couple of questions on the use of your meters. So for instance, are the Elvaco meters available for LoRaWAN on the Australia 915 bandwidth frequency?
They are prepared, but not commercially available for that bandwidth at this point.
And the frequency that must be used. Sorry,
yeah, sorry. No, you go ahead, Anna.
Great. A question on the frequency that must be used for wireless M-Bus in the Americas. Would that be Emil or Ahmed better to reply?
So far, wireless M-Bus is a European standard, and it is mainly targeting 868 megahertz band. We have also other variants in 433 megahertz band. And I think that so far it is not yet authorized in the US to use those frequency bands.
Thank you, Ahmed. To just stay with you, there's a question on the approach M-Bus LoRaWAN. The question is, M-Bus is kept with its applications and LoRaWAN will be just the last mile network? I can get you another question, Ahmed.
Yeah, I don't understand really what does it mean, the last mile network, but it is an end-to-end solution, meaning that from the meter, from the end device to the head-end system, this all will be implementing this M-Bus over LoRaWAN approach.
And is it recommended to develop M-Bus for a greenfield project to connect smart meters with HES and MDM?
No, it is not yet. So let's say that M-Bus is already well established for smart meters and for head-end systems and meter data management infrastructures. And if someone is looking to develop and implement those standards in their projects, there is plenty of existing solutions that will speed up their developments and implementations.
Thank you for answering that question. I do think we have another one for you that is rather technical, and it goes, is M-Bus with two wires using CPL through power line, or does it have its own separate cables?
It has its own separate cables. So this is a dedicated two wires interface for wireless, for M-Bus, sorry, for M-Bus meters.
Thank you. Great. So we've become at top of the hour now. We will, as I said before, extract some of these questions and send you a report. Hannes, I know that you answered a couple of questions directly to our audience today. So thank you for that.
My question is that there are some anonym members. Did they get also the answer? Because I answered them all written.
Yes, we will extract these and send them through to all the attendants. We have the list of attendees.
Okay.
So the webinar has been recorded. It will be made publicly available on YouTube, and we will send out a wrap-up emailing to all of our attendees shortly. Please don't hesitate to contact our speakers directly for any follow-up questions. We thank you very much for your attendance today and looking forward to seeing you on our next webinars. Thank you, everyone.
Thank you very much.
Thank you very much.
Thank you. Goodbye.